All right, guys. Today on your lesson, we're going to be learning a new math process. We've played around with a lot of the parts of it before, but we're going to kind of be putting things together. And you probably saw a problem like this on yesterday's assignment. I kind of forgot that we hadn't gotten this far when I assigned that assignment. So today's assignment is all going to be about practicing this. And the thing we're going to be learning today is called greatest common factor. In math, a lot of times they abbreviate it GCF, greatest common factor. Greatest meaning the biggest thing, common meaning all numbers have it, or the numbers you're looking at all have it, and factor being something you can divide by. So the biggest thing that both numbers can be divided by is kind of how you can translate that. Greatest common factor. Well, let's start just with the idea of a factor. Okay, we've done problems like this before. So you give a number, let's say 28. We ask, well, what are the factors of 28? And this is where we use both sides. We say, oh, there's a 1, and there's a 28, and there's a 2, and there's a 14, and there is a, 3 doesn't do it, 4, and a 7. 5 doesn't do it, 6 doesn't do it, and that brings me to 7, and I'm done. So those are the factors of 28, right? You've done this before to figure out factors. This process is going to be a lot similar to that. You're going to be given two numbers. So for example, let's say we have the numbers 15 and 60. He's going to say, hey, give the greatest common factor for 15 and 60. Well, to do that, you got to break both numbers down into their factors. All right. Now, there's different methods of doing this. We could go back to like what we had when we were just coming up with the factors, and we could string them out like that and do some things with that. But what's probably the easiest way to do this, and the way that'll always get you the right answer, is to do factor trees. Okay, factor trees require you to take the number and draw upside down letter V's underneath them. Okay, or maybe you can think about it like an arrowhead. And what we're going to do is we're going to take two numbers that give me 15 when I multiply them together. So 15 ends in 5, so I know 5 times something. What is it? Oh, 5 times 3. 5 times 3 is 15. All right. After I do that, after I figure out my numbers, I got to ask myself, can either of those numbers be broken down into anything smaller? Well, nothing will give me 5 other than 5 times 1, right? So 5 is kind of as small as it gets. It's what we call prime. 3 is the same way. Nothing can give you 3 other than 3 times 1. So it also is considered prime. All right? And notice that I circled those numbers because they're prime. Now let's take a look at 60. Okay, when I think about 60, it ends in 0. So I know 10 times something will give me 60. All right, well 10 times 6, right? Now both those numbers can be broken down smaller, right? 6 can be 2 times 3, right? Well, let's think about that. 2, can't break that down any smaller, right? 1 times 2 is the only way to get 2. Same thing with 3. We already know 3 is prime, so we're going to circle that. 10 can be broken down. 10 can be 2 times 5. Well, we know 5 is prime, and we know 2 is prime. Okay, so what we've done, we've used a factor tree. That's what this little upside down V thing is. It kind of looks like a Christmas tree over here when you get a couple of them. We've used a factor tree to get our prime numbers, our basic smallest bits that give us the number above. Now we got to look at what they got in common, right? Greatest thing that they have in common. So they both have a 5, right? There's a 5 and there's a 5. And they both have a 3. There's a 3 and there's a 3. So we take what they have in common and we times it together, and that gives us our GFC or GCF. Okay? So 15. All right? 15 would be the greatest common factor between these two. And that makes sense. I can divide 15 by 15 and get 1. And I can divide 60 by 15 and I get 4. All right, let's try another one. All right, again, we're always doing these factor trees on these. For our new one here, we're going to have 20 and we're going to have a 12. We're going to see what's the greatest common factor for 20 and 12. All right, 20 breaks down into 2 times 10. 2 can't get any smaller, so I'm going to circle it. 10 breaks down into 2 times 5. 2 can't get any smaller, and 5 can't get any smaller. I'm done with it. Okay? And again, all we're doing here is dividing. I could be using my list here. I could be, oh, what does 10 break down into? Oh, 10 can be divided by 1. Let's see, 10. I can find it over here. It can be 5 times 2. anywhere in here that you can find 10, that can give you factors, all right? You're just finding it anywhere out here and then seeing what two numbers in the white it leads to. All right, 12, same thing. Got to figure out what leads to 12. So again, if I don't already know off the top of my head, I can find 12 anywhere out here. Oh, here it is. 12 could be 4 times 3, it looks like. So 4 and 3. Well, 3 can't get any smaller, right? There's nothing I can divide 3 by, and other than 3. 4, it can get a little smaller. If I look out here, I can find 4 out here in the colored numbers here. It can be a 2 and a 2. But then 2, it can't get any smaller. All right, I've broken it down into the smallest pieces. All right, now I see what they have in common. That one has a 2, and that one has a 2. All right, let's see what else we got. That one has another 2. That one has another 2. All right, and that's all they have in common. That one's got a 3. That one's got a 5. 2 times 2, that's going to give me 4. 4 is going to be my greatest common factor for 20 and 12. Okay, it's the biggest thing I can divide them both by. All right. The reason we're trying to find greatest common factors is as you work with fractions and bigger division problems and stuff, knowing these can really help you solve those problems. All right, especially when we have to reduce fractions here in a few units. Let's look at some more. Let's do 28 and let's do 36. All right. So 28. I look at my chart, trying to find 28 out here. There it is. 7 and 4. 7 and 4. All right, 36. Oh, let me find it on my chart. 35. Oh, it's not 30. There. Oh, there it is. 36 is 6 times 6. All right. So I'm just breaking these down, trying to get them into the smallest amounts I can. Try to find 7. Well, the only place I can find 7 is underneath 7. 7 times 1, so that's as small as it can get. 4. Let's see. I can find 4 over here. It could be 2 and 2. Okay. Those are as small as they can get. Coming over to 36 is 6 times 6. These are going to be the same. 6 can be 3 times 2. Those are as small as they can get. And that's going to be the same. 3 times 2. Now I got to see what we got in common. Well, not the 7. This one has a 2. That one has a 2. This one has a 2. That one has a 2. So I got 2 times 2. They each have a 2 in common. So that will make it so that for 28 and 36, the greatest common factor is 4. We'll do one more here. All right, for our last one, we got 24. All right, and we got 32. All right, so let's see what we got. 24. Let's see. Oh, it's over here. 24 is 2 times 12. Well, 2 is as small as it can get. How about that 12? 12 could be 6 times 2. Again, 2 is as small as it can get. 6 breaks down into, I already did this one earlier, 2 times 3, and that's as small as they can get. All right, done with 24. 32, let's see here. Where's 32? Oh, there's a 32 right there. It says 8 times 4. Okay, then I break those down. 4, I know it could be 2 times 2. We've done that one a couple times. 8, oh, 8 could be 4 times 2. Oh, and that 4 could be 2 times 2. So I've got all the little bits. I've broken everything down into the smallest things I can divide it out into. All right, now I start seeing what I got in common. I got a 2 there and a 2 here. That's 1 2 that they have in common. Got a 2 here and I got a 2 there. That's another 2 they have in common. 2 here and a 2 there. That's a third 2 that they have in common. This one has a 3, that one has some 2s. They don't have anything else in common. So now I look at my numbers. 2 times 2 times 2. So 2 times 2 is 4 plus, or not plus, ooh, big mistake there. 2 times 2 is 4 times 2 more is 8. 8 is going to be my greatest common factor between 24 and 32. All right, there are other videos obviously out on the internet. If what I'm saying isn't making much sense, I really recommend you go look at the Khan Academy. Go look at, there's just tons of them on YouTube, okay? Math Antics is a good one usually. But the next few problems you're going to have, half of them at least, are going to be these greatest common factor problems. All right, good luck.